After our first design, the group determined that we needed to cut back on 3D printed parts in order to stay within the 500-gram constraint. In order to do this, the group redesigned various parts of our system and used an infill of 10% for non-moving parts and 20% for moving parts. Our total budget consisted of PLA that was used for 3D printed parts, an acrylic sheet that was cut to make some of our gears in the system, a shaft that was used to hold gears and other bearings, as well as screws, nuts, washers, and bearings to provide stability and support within our system.
Initially, our group tried to use glue to fasten the gears and other parts to the shaft. Under loading, this glue would shear off, causing the system to fail. We opted to drill into the shafts and insert self-tapping screws, which proved to be a far more reliable technique when compared to using glue.
powers another middle sum here that is spinning the opposite direction to the gray sum here, which is how we do the front and back. So now we get to the middle. In the middle we have the connector. This one is what shifts in the system. And here's the connector support. This middle part is our brake, so when it's in neutral, nothing is spinning. It's locked on. It won't move. And we can shift it into forward. Here's forward. And back to brake. There's reverse. And then after that we have this set of gears that turns this power 90 degrees into this shaft, which will use for the
Here is the first prototype for the planetary gear set, only able to provide one direction motion. In comparison, this is the final design. The small front gear rotates counterclockwise while the gear just behind it spins clockwise, able to provide both forward and reverse motion.
For our first design, we used spur gear-shaped holes inside the connector to connect both input and output shafts. However, we met several problems with this design. The shifting was not smooth since the spur gear shape inside would create so much friction. And also the overall stability was not that high enough, so sometimes the connector would tilt upward or to the sides, which tremendously impacted the shifting. Those were reasons why we changed the inside of the connector to hexagonal shape.